Hi guys, how you guys doing today? I trust you guys are doing very well. Okay, so today we're going to be treating past questions in chemistry, and we're going to be dealing with the year 2019. Okay, now past questions. All right. Now in these past questions that we're going to be dealing with, there are certain things that we're going to come across, get to learn, and let's study together. Now before I do that, before we start this, I want to quickly bring something to your notice. It's called the Kstudy Exams app. All right, you can find this on your Play Store and your Apple. All right, this could help you in past questions in Jamb and some other topics in Jamb that seems to be like a bit difficult. All right, this is going to help you. So please go to your Play Store and other iOS device and Android apps. Please download and have fun. Now, with that being said, we now go to the solving of today. So let's deal with these questions, shall we? Yes, we shall. All right. Question number 1. Which of the following is a physical change? Which of the following is a physical change? A. Exposing white phosphorus to air. Exposing white phosphorus to air. B. Burning kerosene. C. Dissolving calcium in water. And D. Freezing ice cream. Freezing ice cream. Now, correct answer there is D. All right, our correct answer there is D. Question number 1, D. Question number 2. All right, in the reaction between sodium hydroxide and tetraoxosulfate 6 solution, what volume of 0.5 molar sodium hydroxide would exactly neutralize? All right, 1.25 molar tetraoxosulfate 6 acid. Now we're given, all right, so compounds, and we are asked to find out the volume that will neutralize, all right, the other. So let's do this. All right, so we have two compounds here, sodium hydroxide and tetraoxosulfate 6. Okay, so I'm going to write this now. I'm writing in short form. So we have sodium hydroxide plus H2SO4. Okay, now if we add sodium hydroxide with that, it is going to give me Na2. Okay, there, SO4. Now, what is going to be left? Okay, H2O. Now, I think one of these days I'm going to try to teach you guys balancing chemical equations. All right, so we can learn more and balance more of chemical equations, but then there's no time for that now. So let's just deal with this. All right. Now, with that formula given to us, we are not supposed to find out. Then let's figure out this the equation for the question. Now, concentration of the base. Now we have, of course, both base and acid. This is a base and that's the acid. Now concentration of the base, first of all, is given to us 0.5. All right. Now concentration of the base of the acid too will be there. We've done that of base. Let's do concentration of the acid. So I'm just writing in the short form, concentration of the acid. Okay, so if you look at it, the question says acid will give me 1.25. It is there in our question. All right. All right, that's the concentration. Molar concentration of the acid. So let's go on, and then we have concentration of acid and base. We're going to have volume, all right, of both the base and volume of course, the acid. So we have concentration of acid and base. We're going to have volume of acid and base. Now, the volume of acid has already been given to us, 10 cm. The volume of the acid has already been given to us, 10 cm. So give me 10 cm cube. That's the volume. Then volume of the base. This is not to be given to us because I don't see any volume of the base there. Now I'm looking at the question. I don't see any volume of the base. There's no volume for the base there. Okay, so if there's no volume for the base, then we'll now go straight to solving. So now you have something that whenever you solve, so you have this CAVA all over CBVD. Now, the 0.5% of the acid can, now there's something called the Na, all right, and Ba. The NaBa basically talks about the concentration form of the acid, which is like 0.5. Now, if I break this down, 0.5 is going to give me what you call a 1.2. All right, 1/2, sorry. Now, if you have that, we're going to work with this. So, what I'm going to have here in this case is going to be 1.25 times 10, all right, all over 0.5 times, all right, we don't have this, remember that, right, VB equals to, all right, 1 over 2. All right, you following me? All right, now if we have that, if you impute what we have, okay, if you work with this, all right, impute what we have. If I multiply everything, I would not want to start multiplying then at the space of my board. Like, but if you try to multiply, you're going to have something of this nature, 50 cm. I'm sure the mathematics is easy for you to do at this point. I'm quite sure it's easy for you to do. It's not difficult. Multiply these two you see here, multiply this value and this value together. This is just VB 0.5. This one will cross multiply, this one will multiply this, and this will multiply this. It will be easy for you to do. It's so easy. It's just so easy. Just calm down when you are doing this. Don't rush. All right. One of the most important things I tell students when you're doing this, calm down, have fun. Just look at something, have fun. It's like watching a good movie. Now, when you watch a good movie, you have fun. So have fun. All right. So our answer given to us there is 50. So take a look at the options. You have 25 cm cube, 10 cm cube, 20 cm cube, and 50 cm cube. Now, our answer on question number 2 is D. All right. Question number 3. Number 3. Sulfur exists in 6 form in the solid state. This property is known as, I'm taking that again. Sulfur exists in 6 form in the solid state. This property is known as A. Isomerism, B. Entropy, B. Isotopy, and D. Isomorphism. All right. The first thing that might probably come to a lot of your mind is isotopy, but no, isotopy is not the correct answer. Basically, elements exist in 2 different forms. All right, but now that's not it. They say sulfur exists in 6 different forms. Now, if you study through your chemistry, there are basically 3 forms that are more important in these 6 different forms. All right, basically 3 forms. They have the rubber sulfides, the monoclinic sulfide. I have the plastic sulfide. Okay, basically those 3 are the one that is focused more. All right, now sulfur exists in 6 forms. All right, the property is not known as the A you see. The B is the correct answer, the entropy of sulfide. So our correct answer for question number 3 is B. All right. Now, if you study through, like I told you, all right, most textbooks or most most Google sites or place you go to, they'll tell you that 3 of them are most important. And sometimes you might just think it's only of 3 forms, but a lot of book, oh yeah, I think so, talks about it being more than that. All right, but this is easier to do with. So 3 most important forms are what I mentioned. I think I should write that on the board for you guys so that you see it in case some of you are taking little notes on this. Now these other 3 forms I'm showing you, now they have their importance. So if you want to study more on this, it won't be a bad idea. I think you should study more if you have the time. All right. If you have the time to study more, so to help you understand more on this in chemistry. Okay, now without wasting much time, let's go to question number 4. On question number 4, in the reaction, you have M plus N equals not giving you P. All right, and you have change in H. Okay, equals okay. In that reaction, that you saw the board, okay, which of the following would increase the concentration of the products? Which of the following will increase the concentration of the products? All right, A, adding a suitable catalyst. B, increasing the concentration of P. C, increasing the temperature. And D, decreasing the temperature. A lot of times, all right, for a reaction concentration to be increased, temperature needs to be increased. Okay, so our final answer on question number 4 is C. Question number 5. A compound contains 40% of carbon, 6.7% of hydrogen, and 53.3% of oxygen. If the molar mass of the compound is 180, find the molecular formula. Okay, shall we? Yes, we shall. All right, let's clean this off. All right, okay. Now, that give you options: A, C3H6O3, B, C6H6O3, C, C6H12O6, and D, CH2O. Now, I think I should just write this on the board. Okay, but you see the options there. The options are looking at you. So just write them somewhere. So when we solve, you can even just pick your answer and say, okay, that's the correct one. That's the correct one. Okay. So now I'm going to break this down in simple ways. Now we'll get there. In brackets, you have hydrogen equals 1. All right. That C, that's carbon equals 12 and oxygen equals 16. Basically, the molar mass. So now we're going to break this down first. Let's see. I'm going to take this one first. All right. 40 over 12. That means the percentage all over is mass. Okay, I'm bringing that first. That if you divide that, all right, it's going to give you something. Let me still move on. Now 3 point something. All right, but I just want to stop at 3. Now, if you go on to the next one, hydrogen, it's going to give me, that will be 6.7 over 1 is something like 6.7. Oxygen, that will be O for 16. Okay, that will give me 53.3 all over, all right, 16, approximately 3. Approximately your answer to that. Now, if you have that, now the next thing you're going to do next, when you have 3 of them that you see, is basically divide with the lowest form of numbers in 3 of them. It's like doing a empirical formula. All right. Now, the lowest is 3. So what I'm going to have here first is going to be 3 divided by 3. I'm going to have 6 over 6.7 divided by 3. I'm also going to have 3 divided by 3 here. So this is going to give me 1 now. All right. This is going to give me approximately 2. But I don't want to waste time, just approximating your answer. And this is going to give me also 1. Then if you once you have gotten all 3 of them, remember there are 3 compounds involved in this. All right, remember there are 3 compounds involved in this. Oh, sorry, 3 elements involved in this. Then if we want to put that into place, what I'm going to have, all right, it's going to be 66H12O6. All right, 66H12 and O6. My correct answer for number 5 is C. Okay. Question number 6. The IUPAC nomenclature of the compound. The IUPAC nomenclature of a particular compound I'm saying. The IUPAC nomenclature. I'm going to write the IUPAC nomenclature quickly. Alright. The IUPAC nomenclature. I'm having this. Okay. CH into CH3. Okay. CH into CH3, and then lastly, I think I'm going to CH3, CH3, yeah. Okay, CH2, then CH3. Okay, the IUPAC nomenclature of that. Let me confirm what I have here. CH. Okay, I'm trying to reconfirm so that I don't have an error on what I'm doing. Okay. Yep, yes, we good, be good. Now, if I want to write that out, 1, 2, 3, 4, 5 carbon. So I have 1, put my hand little 1, 2, 3, 4, 5. That's my 5 carbon, my hydrogen. Okay, 1 and 2 and 3. I think on a good day, we're going to have a class on this, so we'll learn how to write this properly very well. Okay, and the next one I'm having is CH3. Okay. And an H, yeah, that's okay. The next one I'm also going to have is CH3 here. Of course, it's going to be an H here. And the next one I'm going to have H, okay. Then, and finally an H and H. Okay, so now we have 1, 2, 3, 4, 5. Okay, if I have 5, if I want to name this compound, let's take a look at our options. 3, 4 dimethane hexane, 2, 3 dimethane pentane, 2 hexane hexane, and 2, 3 dimethane hexane. I just mentioned A, B, C, and D for you. Then let's take a look at this. Now, if you look at the structure, you see from the beginning, this is 1, 2. That is a methane, right? There's another methane here. So I can easily just say first, there's a 2 first. This is number there that I told you. There's a 3. Okay. Then that is methane. So I will say 2, 3 dimethane. Dimethane. Alright. First. Then the compound 1, 2, 3, 4, 5. That is a pentane. So to 3, dimension 13. Dimension 13. All right, my answer on that is B. Question number 6. Question number 7. Which of the following gas or gases contains the least number of atoms at STP, standard temperature pressure? Which of the following gases contain the least number of atoms at STP? All right, so I'm going to clean this. Please, if you're writing this, I think you have to be a bit fast. All right, I'm cleaning this. Which of the following gases contain the least number of atoms at STP? Now, A gives us 1 mole of butane. I'm going to write that out. 1 mole of butane. 1 mole of butane. Okay. B gives us 4 mole of chlorine. All right. Let's see. I have 3 moles. I'm writing this for a reason so that it will help us solve of ozone. Okay. And the last one is 7 moles. 7 moles of argon. 7 moles of argon. Now, if you take a look at what we have there, pick out their, basically what I call their oxidation number. All right, so basically this 1 mole of butane, you're going to have C4H10. That's what you have for butane. All right, chlorine, you're going to have, chlorine is, if you look at chlorine, all right, you see that, right? So I'm going to have a 2 times 4 mole. I'll give me 4 times 2, which is 8. Okay, there are 3 moles of ozone. Ozone is, right? All right, I'm writing it down. Ozone is that, yes? So I'm going to have 3 times 3, which is 9. All right, 3 moles times what you have for ozone, which is 3. Then the last one, argon, is basically just plus 1. All right, so what you're going to have is 7 mole times 1, which is 7. On look of things, we were asked the question, which of the following gases contain the least number of atoms at STP? Yes, our answer is argon. So that answer there for number 7 is C. Question number 8. Question number 8. What mass of magnesium will be obtained by passing a current of 2 amps? All right, the usually people say ampere. All right, but just use the word 2 amps. Okay, what masses of magnesium will be obtained by passing a current of 2 amps for 2 hours 30 minutes through the molten magnesium chloride? Now we're giving 1 Faraday as 96500. All right, 96500, and magnesium is giving us as 24. That is okay. So let's see. Okay, now if you want to convert that, let's convert our time first. We said 2 hours. Now I'm taking the time to seconds, but I'm going to, all right, so 2 hours 30 minutes. 2 hours 30 minutes is going to give me, if you multiply that, it's going to give me 120 minutes, because an hour is 60 minutes. Okay, so it's going to give me 120 minutes plus, let me write that minutes very well, 120 minutes plus 30. That will give me 150 minutes. Now I told you I'm taking it to seconds. So I'm taking it to seconds, I'm going to have 150 minutes times 60 seconds. Okay, times 60 seconds. If I'm doing that times 60 seconds, if you calculate very well with your calculator, you're going to have 9,000 seconds. Now, taking out 9,000 seconds. Now, okay, let's go on. If I want to now solve this, I'm going to place Q equals to I times T, which is going to give me 2 times 9,000 first, which is going to give me 18,000. Yep. Okay. Then finally, what I'm going to do, okay, it's going to be this: 24 times 18,000. All right. All over. All right. 2 times 96500. Okay. All right. You see that, right? Then from what I have there, if I punch through my calculator very well, multiplying the first 2, I am going to have, okay, 423, okay, all over 193, all right, 000. Then if you divide properly, you can have 2.9. Okay, it's 2.19. All right, now approximately, if you look at your answer, A 1.12, B 4.48, C 1.80, and D 2.00. My answer approximately is what you see. Now I can't take this one, just let go. So my answer there on question number 8 is D. Question number 9. Question number 9. All right. Which important nitrogen containing compound is produced in Haber process? Which important nitrogen containing compound is produced in Haber process? It can only be one, but let me mention the options. A, NH3, that's ammonia. B, NO2, C, NO, and D, HNO3. All right, my final answer there is A. All right, that's an important nitrogen containing compound that is produced in the Haber process. Ammonia can be gotten using the Haber process. So question number 9, I have A. Question number 10. Elements in the periodic table are arranged in order of their A, atomic number, B, metallic character. No, because not all elements are metals. C, mass number. D, relative atomic mass. Relative atomic mass. Now some of you will be thinking, nah, my answer is D. No, your answer is A. Elements on the periodic table or in the periodic table are arranged in order of their atomic numbers. Atomic numbers. So my answer on that question number 10 is A. Elements are arranged on the periodic table based on their atomic numbers. Okay, question number 11. Let's go. What volume of 0.100 m sodium hydroxide 5 solution contains 5 grams of solute? Now in brackets, let me do this quickly. I'm solving this straight up again. Now, I don't have to be telling you to do that. These are the mass numbers. I'm sure you should know by now. And when you comes to questions like this, you're always dealing with mass numbers. Okay, so what the problem are giving to us. Now we are asked to find out volume of sodium triosonitrate 5. Sodium triosonitrate 5. Sodium triosonitrate 5. I'm going to have this. That's the compound given to us. Sodium triosonitrate 5. Now, first of all, add their mass number together to get basically the general mass of the compound. So if I'm going to add their mass number together, I'm going to have 23 plus this, that's 14. All right. Plus, that 16 is there, but it's 3 here. So we have 16 times 3. Okay? And when that is done, if you multiply it properly very well, you're going to have 85. Now, that's the mass number of the compound, the molar mass of the compound. So now, if you have that, now we're going to just now take basically to this. N is equals to, now I'm going to write it this way. I want you guys to figure out what I'm trying to do here. Let me see what, maybe you can catch what I'm trying to do. 5 over 85. Where did I get the 5 from? Where did this 5 come out from? I wrote it for a reason. Look at the question. 5 grams of solute. The 5 grams. So basically the gram of the solute, the mass, because gram basically represents mass also. Now the mass of the compound involved. Alright, so now if we do that, if I break that up, I'm going to have 0 points, okay? 0.058 alright, moles. Okay, once I've gotten that, that is not my final answer. I'm now going to divide by what volume of, I'm going to divide by what I have there, 0.100, alright? So this will be divided by that. I'm going to finally have 0.00588 divided by 0.100. When you divide that, you're going to have 0.588. Take a look at your options. But A says 1.7, B says 0.42, C says 0.588, and D says 2.35. So by 11, our answer there is C. Question number 12. The 2 ions responsible for hardness in water. The 2 ions responsible for hardness in water are A, Ca2, Mg, that's calcium and magnesium. That's for A. B, you have potassium and magnesium. C, you have calcium and lithium. D, you have calcium and sodium. My answer is A. If you are studying hardness of water in your chemistry, you will understand this part. It's just basically the 2 ions that is responsible for the hardness of water. So our correct answer in question number 12 is A. Question number 13. Which of the following could not be an alkane? Which of the following could not be an alkane? Let's do this. All right. Let's do this quickly. Which of the following could not be an alkane? Now, an alkane basically has a general formula. Okay, so that's the general formula. Cn, okay, H2n plus 2. That's the general formula for alkane. Now, how do you now know which to work with? I'm going to bring out all the options. We're going to work with all of them. All right. So now understand how you understand this. Okay. Let's see. First one in A, I have. Let me roll the line here. I put A first. I have C4. Then you have H10. Okay. Second one, I have C5. That's option B. I have H12. Option C. It's on the other side of my page, so please hold on. Okay, I have C7, H14, and the last one I have C8 and H18. Now, so question says, which of the following, okay, could not be an alkane? One of them there is definitely not an alkane. Let's take a look at the first one. Now, I'm going to calculate it in a way. Now, let's assume N is 4. All right. If N is 4, we have to get this one. I'll put it in the calculation. So I'm going to have C 4. All right. H 2 into 4. That's 2N. That's 2 times 4 plus 2. So C4 H 2 times 4 is 8. 8 plus 2 is 10. So number one first, that's an alkane. They say which of the following could not be an alkane. All right. So that is an alkane. Then the next one. Let's go on. All right, I'm going to put that, I'm going to roll a line here and do the second one. So the second one, I'm going to have C5, right? All right, so C is N, 5 is there. I'm going to have H2 into 5, right? Yes. Anyway, so plus 2. So we need C5, H 2 times 5 is what? 10. 10 plus 2 is 12. That is an alkane. Take a look at the third one. I'm smelling something. That third one looks fishy. So then let's fish it out. Looks fishy. Let's fish it out. I like that. All right, let's go. So C7 H2 into 7 plus 2, right? Okay. C7 H14 plus 2. That's C7 H16. Now working. That's working. So this is supposed to be the odd one out, right? But let's stop there. Let's find out the last one. So last one, I'm going to look at C8 H. That will give me 2 into 8, right? Plus 2, right? So that's C8. But you're already ahead of me. You're putting your answer. Don't do it again, sir. We know. 2 times 8 is 16. That'll be 8, 16 plus 2. That'll be C8, H18. Yeah. So our correct option there in that question is what? C. All right. I'm sure you get the survey now. So question number 13, my answer is C. On question number 14, the electronic configuration of element Z, all right, is 1s2, 2s2, 2p6, 3s2, and 3p1. All right. What is the formula of the compound formed between Z and tetraoxosulfate 6 ion? You have A, Z3, SO4, and 2. Okay. And okay, let me write that. So don't look as if I'm trying to bring it up. Let me just write that. All right. So let's do this. So I'm going to have Z3. All right. SO4, 2. Okay, that's the question. Option A. ZSO4, that's option B. Z2SO4, that's option C. And D is Z2 into SO4, 3. The option is actually this. Time to explain this, I will do that, don't worry. All right, let's go. So question number 14, I will have D. Question number 15, the hybridization, the compound, CH3, CH2, CH3, CH2C, and there's a triple bond there H. So question number 15 is A. Number 16, all right. The following are isoelectronic ions, except. The following are isoelectronic ions, except. Now, isoelectronic ions means their electronic configuration are basically like the same. Like sodium, you have 2 8. Like magnesium, you have 2 8. Now, when I mean 2 8, it means they have other letters to give out, but maybe 1 or 2. So they are complete. You have the 2 8 in sodium, magnesium, you have the 2 8. The Si, which is the silicon, you have the 2 8. All right. And oxygen, you have the 2 8 2. All right. The one that is not supposed to, the odd one out there is basically what you see last year, the 282. So our answer on that question, all right, is D. Question number 17. We consider the reaction A plus 2B, all right. Now there's forward and backward reaction 2C plus D, all right. Now there's an energy level there, all right. That energy is a plus there, so that's an endothermic reaction. So which will be the effect of decreasing temperature on the reaction? Which will be the effect of decreasing temperature on the reaction? A, rate of backward reaction will increase. B, the equilibrium constantly will shift. C, rate of forward reaction and backward reaction are not affected. And D, rate of forward reactions will increase. My answer on number 17 is A, rate of backward reaction will increase. Number 17 is A. Question number 18. A shorthand notation can be written as, all right, a shorthand notation as it was given, you have A/A plus, you have this, okay, then you have this, all right. The double slash in the notation represents what? It has to be a salt bridge. I didn't give you the option, I just want to read the answer straight. Option says electrolyte, B says electroid, C says salt bridge, and D says solid liquid interface. Our answer that has to be a salt bridge, all right. So question number 18 is C. All right, number 19. The shape of water, ammonia, carbon dioxide, and methane are respectively. You have A, linear, tetrahedral, angular, and pyramidal. B, angular, pyramid, linear, and tetrahedral. C, pyramid, linear, tetrahedral, and angular. D, tetrahedral, angular, pyramid, and linear. Our answer in that one is angular. That's B, angular, pyramid, linear, and tetrahedral. That is it. So the shape of water is angular, ammonium is pyramid, carbon dioxide is linear, and methane is tetrahedral. So question number 19 is B. Before we go to our last question, number 20, please remember our Kstudy exams. Very important in your Jamb past questions and other exams that will be useful to you. I promise you that it's going to be useful to you because you're going to find a lot of videos there that will be very useful to you. Then last but not the least, what quantum divides shells into orbits? What quantum divides shells into orbits? A, spin, B, principal, Z, azimuthal, and D, magnetic. Our answer on question number 20 without wasting time is only one, which doesn't need much, is C. So question number 20 is C. So that will bring a pause to our class for today because I told you it's just the first part of the question. We're going to continue shortly. I'll be chill. I will see you guys later. Bye.